All right, let's talk about inverter reliability for a minute. When you think about what makes an inverter good, what's the first thing that comes to mind? It's easy to get lost in the specs, the price tags, but there's this silent killer that can totally make or break your business over time, and that's heat. So let's dive right into that.
So let me just ask you this. Picture a blistering hot summer day. The system is working its absolute hardest. What's the real enemy here? It's not just the sun beating down. Nope, it's the heat that gets trapped inside that box.
And that's exactly where we're going to start. We need to stop thinking of heat as just a little side effect. It's the silent killer. We're going to crack open the box, so to speak, and see exactly what it's destroying first.
This right here is a huge shift in perspective. You've got to understand this. Excess heat isn't just some small inconvenience that a fan is supposed to fix. It's a fundamental design flaw. It's a structural problem that weakens the entire system from the inside out.
And look, heat doesn't just attack randomly. It has very specific targets. We're talking about the absolute heart of the system, the power components, your IGBTs and MOSFETs. We're talking about the DC link capacitors, which are critical for delivering smooth, stable power. And the real irony, the cooling fans themselves, the very things designed to fight the heat, they get stressed and worn down by it too. The math is simple. A cooler inside means a longer life for every single one of these parts.
To really get why this matters, let's look at those capacitors for a sec. They're under constant stress from something called ripple current. Just think of it like unwanted electrical static or vibration that happens during the power conversion process. And here's the key. Heat makes that vibration so much worse. So when you lower the temperature, you're basically calming everything down, and that dramatically extends the capacitor's life.
Okay, so a little extra heat. What's the big deal, right? Well, it's not just one thing. It's a domino effect. It's a totally predictable chain reaction that can turn a couple of hot days into a complete and total system failure.
And you can see that whole path laid out right here. It always starts the same way, heavy use in the summer, which is exactly when you need the system to perform at its best. That pushes the internal temperature way up. In turn, that puts massive stress on those key parts we just talked about. And then, you get the thing everybody dreads. Alarms go off and the system just shuts down. This isn't random chance. It's a predictable breakdown.
And let's be real, if you're working in a hot climate, we're talking the Middle East, Africa, Southeast Asia, this isn't some what-if scenario. It's an absolute expectation. In these places, an inverter that runs hot is practically guaranteed to come back as a return. Failure is pretty much baked right into its design.
So we've talked about the tech stuff. Now let's get to what really matters, how this hurts your business. Because when an inverter fails, it's your time, it's your money, and it's your reputation that's on the line.
I mean, just look at this breakdown. For installers, it's an absolute nightmare. More service calls, hours wasted on site, and those awful, frustrating arguments with customers who just want what they paid for. And for distributors, it's a direct shot to the wallet. More repair costs, a flood of returns, and ballooning support costs. Both sides of the coin get hit hard by a design that just can't take the heat.
So what's the way out of this mess? Well, it's what we're calling the cooler design advantage. And listen, this is not just another feature you check off on a spec sheet. This is a fundamental design philosophy that stops these problems before they can even start.
The solution here isn't about slapping on more fans or bigger heat sinks. That's just treating the symptom. The real solution is designing the system from the ground up to not create all that extra heat in the first place. You've got to go after the root cause.
And there it is. This is the simple, powerful logic. An inverter that runs cooler leads directly to a longer lifetime for all its parts. That longer life means higher stability. And that stability is what gives you what everyone actually wants. Stronger, more reliable performance out in the real world, especially when it's hot outside.
So this brings us to the final and honestly the most important point of all. We have to completely change how we think about cost. It's not about the number on the price tag. It's about the true cost, the real cost over the life of the system. This table right here, it says it all. That hotter design looks pretty tempting, right? Low upfront price, but you fast forward 5 years and after you add up all those truck rolls, all the replacements, the warranty claims, the total cost of ownership, the TCO, is through the roof. The cooler design might cost a little more on day one, but it ends up being so much cheaper to support in the long run. It's not even close.
This quote really nails it. It's a clear warning. A design that's prone to overheating isn't just a minor issue. It's a deep structural problem. And it's a problem that will, without a doubt, hurt your performance, your reliability, and your bottom line.
So the next time you're sizing up a new inverter, I'm just going to leave you with this one question to think about. Are you looking at the price tag, or are you looking at the price of failing?